Hello, my name is Imran Munaf and this is my teammate Noman.
So we are the students of Endeavour Academy. Our mentor was TechTics Clubs and we are from Pakistan.
We are proudly participating in IEEE SSCS Arduino contest. There were 16 challenges in total where we performed 10 record challenges. Also, we faced many difficulties along the way, but we somehow managed it.
Now we would like to present our 10 project challenges that we have completed.
This is light sensor. Our challenge was to create an automatic lighting system using a light sensor. A light sensor detects the intensity of light around it. When the environment becomes dark, the light sensor detects the low light level and sends the signal to the system. The system then automatically turns on the light. When there is enough light, the sensor detects brightness and keeps the light turned off. This project helps save energy because the light only turns on when it is needed. This is piezo buzzer. Our challenge was to control the sound of the piezo buzzer using two potentiometers. The first potentiometer is used to control the pitch of the buzzer. By rotating it, we can increase and decrease the frequency of the sound, which changes how high and low the sound is. The second potentiometer is used to control the sound level. By adjusting it, we can increase and decrease the volume of the buzzer according to our requirement. This project demonstrates how input devices like potentiometer can be used to control output device like a piezo buzzer. It can be used in alarms, musical instrument, and electronic sound system. This is keypad. Our challenge was to create a secure locking system using a keypad and servo motor. The keypad is used as an input device where the user enters the password. The system checks the entered password and completes it with the stored password. If the password is correct, the system sends a signal to the servo motor. The servo motor rotates from the lock position to the unlock position, allowing the door to open. If the password is incorrect, the servo motor does not move, and the door remains unlocked. This helps providing security and prevent unauthorized access. This project can be used in smart homes, lockers, and security systems. This is LCD display. Our challenge was to create a digital stopwatch using an LCD display and a push button. The LCD display shows the time recorded by the stopwatch. When the stopwatch starts, it counts the time continuously and display it on the screen. A push button is connected to the system as a reset button. Whenever we press the push button, the running stopwatch automatically reset and start counting again from zero. This project demonstrates how input devices like push button can control output devices like LCD display. It can be used in timing system, sports activity. This is analog input. Our challenge was to control LED brightness using an analog input device, which is a potentiometer. The potentiometer provides different analog values when it is rotated. These values are read by the system and used to control the brightness of three LEDs. When the potentiometer is turned, the LED turns on step by step. First, the first LED starts glowing from low brightness to high brightness. After that, second LED increases its brightness, and then third LED follows the same process. This project demonstrates how analog inputs can be used to control output devices. It can be used in lighting control system.
This is digital input. The push button is the digital input and LED is the output. Whenever I press the button, Arduino detects the input and makes the LED blink. This project can help others how in digital input and digital output works and how Arduino can be used to control electronic components. This basic idea can be also used in real life projects such as alarms, emergency buttons, switches and smart devices. This is serial bus. Whenever I press the push button, the Arduino detects the input and displays high on the screen. When I release the button, it displays low. This project helps others understand how Arduino can read digital signals and communicate information through the serial monitor. It can be useful for testing buttons, serial sensors, switches, and other electronic components. This is temperature sensor. As you can see, when the temperature reaches 35 Celsius, the Arduino detects the temperature and turns on the fan. When the temperature drops to 34 Celsius, the Arduino turns off the fan. This project can help others by showing how temperature can be monitored and controlled automatically. It can be useful in such systems such as automatic cooling, smart homes, computers, and electronic devices where a fan needed to turn on or off. This is PWM output. The potentiometer acts as an input. When I turn it, the Arduino reads the changing value and uses PWM to control the brightness of the LED. Turning the potentiometer one way makes the LED brighter, while turning it on the other way makes it dimmer. This project helps others understand how PWM can be used to control the power of an output device. It can be useful in real life applications such as controlling lights, adjusting motor speed, and creating automatic brightness controlling system. This is digital output. The Arduino turns the light on and off in a specific sequence. It's like a real traffic signal. This project helps others understand how digital output can control multiple devices using Arduino. It can also be useful for learning how traffic signals work for developing smart traffic control system in the future.